So today what we're going to be working on is factoring by the difference of two perfect squares. Okay, so I'd like you to try this. Try this as to make a list of the first 12 positive perfect squares. So which means I don't want you starting with 0. So put me a pause and you could do that. And then come back, check your answers. Okay, so let's just talk about what a perfect square is. A perfect square is the product. Remember, product means the answer to a multiplication problem. The product of a number multiplied by itself. So the first smallest positive perfect square there is would be 1, because 1 times 1 is 1. And then we have 2 times 2 is 4. So 4 is a perfect square. Then we have 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121, and 12 times 12 is 144. That's the first 12 positive perfect squares. So now remember, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. It's asking, when you ask for a square root of something, it's asking what number multiplied by itself gives you the number under the radical, which is the radicand. So the square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 is 11, and the square root of 144 is 12. And obviously, the numbers keep going on and on and on forever. All right, so now let's talk about what a perfect square that is a variable is. So let's write down a perfect square variable is if the exponent of the variable is even, then it's a perfect square. Okay, so if the exponent is even, so let's start with the smallest. So we have x squared, or it could be y squared or z squared, a squared, b squared. That's a perfect square. Remember, it has to have an even exponent. My exponent is a 2. All right, next would be x to the 4th, and then x to the 6th, and then x to the 8th, x to the 10th, and so on. So the square root of x squared is just x, because x times x is x squared. The square root of x to the 4th is x squared. The square root of x to the 6th is x to the 3rd. So notice, to get the square roots, it's half the exponent, right? Half of 2 is 1, so my exponent is a 1. Half of 4 is 2, so the square root of x to the 4th is x squared. Half of 6 is 3, so the square root of x to the 6th is 3rd. So the square root of x to the 8th would be x to the 4th. And the square root of x to the 10th would be x to the 5th. All right, so now let's talk about how to factor using dots. I'm sure you've heard that before, or difference of two perfect squares. All right, so first of all, you do have to have certain conditions in order to factor by difference of two perfect squares. You must have 2 terms. So this does not work for trinomials, 4 terms. It has to be 2 terms. It must be subtraction. Has to be subtraction. You must have perfect squares. So your numbers have to be perfect squares. Your variables have to be perfect squares. Okay? Those are these here, these first 3 are conditions that you must have. Okay, now how do we set it up? So you're going to use two sets of parentheses. One will have a plus, one will have a minus. You can flip-flop them. You can put the minus first and then the plus. It doesn't matter because multiplication, remember, factors multiplication is commutative. And then you take the square root. You take the square roots of the numbers and you put it inside the parentheses. Do remember to keep the given order, and I'll show you what that means in a second. All right, so let's take a look at number 1. All right, and it does say to factor by dots. So I have x squared minus 25. So you first look, 2 terms, yes, 1 term, 2 terms. It is subtraction. Okay, and x squared has an even exponent, so that means it's a perfect square, and 25 is a perfect square. So we're going to set up our 2 parentheses. One's going to be a plus, one's going to be a minus. And now to get what goes inside the parentheses, you take the square root of these numbers. So the square root of x squared is x. So each one gets an x in the front. And the square root of 25 is 5. So each one gets a 5 at the end. So what I mean by keeping the given order is it has to, see, notice in this polynomial, the x comes first in 25. You have to have the x come first and then the 5. So you cannot write it like this. You cannot write 5 plus x and x minus 5. Okay, so that's no. All right, so let's take a look at number 2. 2 terms, 100 minus y squared, y to the 6. We have subtraction. 100 is a perfect square, and y to the 6 is a perfect square. I have an even exponent. So let's set up the parentheses, 2 parentheses. I'm going to put the minus first and then the plus, because remember I said it doesn't matter. Then take your square roots, the square root of 100, square root of y to the 6th. The square root of 100 is 10. So each one gets a 10 in the front. And the square root of y to the 6th is y to the 3rd, so each one gets a y to the 3rd. So it's 10 minus y to the 3rd times 10 plus y to the 3rd. Let's take a look at number 3. I have x squared y to the 4th minus 36. 2 terms, subtraction, x squared is a perfect square, so is y to the 4th, and 36 is a perfect square also. So let's set up the parentheses. One's going to get a plus, one's going to get a minus. Let's do our square roots in here. The square root of x squared is x. The square root of y to the 4th is y squared, so that gets a y squared with the x here. And the square root of 36 is 6. So each one gets a 6. Okay? And number 4 here, we have 4a to the 8th b squared minus 64x to the 10th. All right, so everything is a perfect square, so let's set up the parentheses. So I have 2 parentheses here. Just going a little bit lower here to give myself a little bit more room. I'm going to put the minus and then the plus here. So we're going to do square roots here. Okay, so the square roots. The square root of 4 is 2, so each one gets a 2. The square root of a to the 8th is a to the 4th. And the square root of b squared is b. The square root of 64 is 8. And the square root of x to the 10th is x to the 5th. Okay, so I want to go over a couple more types of problems. And now that's combining yesterday and today. All right, so that is called factoring completely. Factoring is factoring until you can't factor anymore. So when you factor, you should always be looking for a GCF first. Okay? So let's take a look at number 1. 2x squared minus 72y to 2nd. So I notice I have a 2 and a 72. They're both even. All right, so obviously 2 has to go into 72. This one has an x, this one has a y, so no GCF there. So we're going to factor out 2 as the GCF. So let me just write GCF up here. Is 2. Remember, we divide everything by 2. And then we put the GCF on the outside of the parentheses. And then we get x squared minus 36y squared. And then I notice inside the parentheses, I do have dots. 2 terms, minus, and both terms are perfect squares. So we're going to set up 2 parentheses right below it. Bring down the GCF of 2. Now take the square root of these. The square root of x squared is x. So it's going to be an x plus x minus. And the square root of 36 is 6. And the square root of y squared is y. So it's 6y. All right, let's take a look at number 2. So I have 8, a to the second, b to the fourth minus 32. So 8 does not go into 32, but 4 goes into 8 and 4 goes into 30. No, the 4 does not go into 32. So it has to be 2. 2 goes into 8 and 2 goes into 32. So 2 would be the GCF here. So GCF is 2. So we're going to divide by 2 here. I'm going to put it down right down here. So we have 2 on the outside, and then we get 4a squared b to the fourth minus 16. Okay, and then we have dots inside here. 4 and 16 are perfect squares. A to the second, b to the fourth, those are perfect squares also. So I'm going to set up my parentheses, 2 parentheses. Put the 2 on the outside. One's plus, one's minus. And I don't think I have enough room, so I have to get a little bit more room here. All right, so I put 2 on the outside, 2 parentheses. One's plus, one's minus. Okay, so let's do the square root. Square root of 4 is 2. The square root of a squared is a. And the square root of b to the fourth is b squared. Square root of 16 is 4. All right, let's take a look at number 3. So I have 9p minus p to the 7th. So it looks like it's just p is the GCF, right? They both have p, and it's p to the first is the GCF, because that's my smallest exponent. So GCF is p. So divide everything by p. So it's p times 9 minus p to the 6th power. And then again, this is the difference of 2 perfect squares. 9 is a perfect square, p to the 6th. So we have 2 parentheses. One's plus, one's minus. Put the p on the outside. That's the GCF that follows down. The square root of 9 is 3. The square root of p to the 6th would be p to the 3rd. That's a 3 in there. Okay, and last one, number 4. All right, so let's see here. So I have 12 and 300. There is a GCF with that. And actually it is 12. 12 does go into 300. So the GCF is 12. All right, we have an m to the 3rd and an m. So m is part of it. An n and then an n to the 11th. So that would be also n. So it'd be 12mn. All right, so it's going to be 12mn times m squared minus 25 n to the 10th. All right, and then we do have difference of 2 perfect squares inside the parentheses. So set up your parentheses. Bring down the 12mn. The square root of m squared is m. So it's going to be m plus m minus. The square root of 25 n to the 10th would be 5n to the 5th. Okay, so that is it, and we will practice in class tomorrow. So everybody have a good night.